right, so let me read this paragraph here. An equation that contains two or more letters that represent constants or variables is called a literal equation. Formulas are great examples of literal equations. If one of two or more of the variables in the equation is present only to the first power, and it's always to the first power if you don't see an exponent, we can solve for that variable by treating the other variables as constants and using the same steps that we used to solve a linear equation in one variable. This is often useful because it is necessary to get equations in the proper form to enter them in a graphing utility. So for example here, if you notice, it is always y equals, y1 equals, y2 equals, y3 equals, so on. So if our equation is not solved for a variable or solved for y, we have to be able to rearrange it so that we can input it in here. So in example 4, we need to solve c equals for h. So I want to solve for this variable right there. So it tells me to treat all other variables as constants. So how would I get this entire term over to the other side? Well, the opposite of adding 2 pi r squared would be to subtract 2 pi r squared. So I am going to subtract 2 pi r squared to both sides. So it cancels over here. These are not like terms, we'll just go side by side. We've got c minus 2 pi r squared equals 2 pi r h. Right, I am still solving for this variable here. So what is happening between this variable that I'm solving for and 2 pi r? Those are all being multiplied together. So the opposite of multiplication is division. So I'm going to divide both sides by 2 pi r. Now we have to be careful here. On this side, 2 pi and r are all going to cancel. That's the whole reason we divided. So I am left with just h over here, which was the goal, solve for h. Over here, my 2's do not cancel, my pi's do not cancel, and my r's do not cancel because I have two terms here, and both of those terms are getting divided by 2 pi r. So because this c has no 2, has no pi, has no r, I cannot cancel those out. So my final answer is exactly this. We have c minus 2 pi r squared all over 2 pi r. Now we could write our solution a little bit differently if we wanted to. That would be an equivalent answer. So as I said, this 2 pi r is getting divided by both of these terms. So that would be the same as c divided by 2 pi r minus 2 pi r squared divided by 2 pi r. If I split this up and divide both of these by that one term here, then you can see nothing cancels for c. So that would stay as c over 2 pi r minus, now I can cancel some stuff out here. Now 2 over 2 cancels, pi over pi cancels, and r squared over r would cancel the r on the bottom and leave me 1 r on the top. So this would be minus r. So these two solutions are the same thing. They're equivalent. To me, I don't want to go one more step because if you make a mistake going that one more step, I'm going to have to count something wrong over here. So I would just personally leave it this way here. But if you want to cancel, you've got to split it up. Okay, now let's solve part B for t. So t is here in the middle. So what I'm going to do first is distribute in that P. So we're going to do P times 1 and P times RT. So I've got A equals P plus PRT. Solving for this T right here. So the first thing I need to do is get rid of this P. So the opposite of a positive P is a minus. So we will subtract that over. These are not like terms. So we just have A minus P equals, and then over here we have PRT. Now, if I'm solving for, again, T, what is happening between P, R, and T? Those are all being multiplied. So the opposite would be to divide. So we'll divide both sides by PR. So these P and R's cancel. I am left with T. What's my final answer on this side? Very similar. I cannot cancel out these P's because A is also being divided by P and it doesn't have a P to give you. So my answer is A minus P over PR. Again, if you wanted to, we could divide both A and negative P by PR. We would say this is A over PR minus P over PR. Okay, nothing has like variables here, so that will stay as A over PR minus these P's here cancel, leaving that 1R in the numerator, or sorry, the denominator. So 1 over R, that's what that would simplify to. Okay, so those are the same. But to me, just leave it this way if everything's not going to cancel, because here we can make mistakes. And this really isn't much more of a prettier answer than this one is here. Okay, but that is why we cannot cancel these P's, because we're dividing two terms by it. So if it doesn't go into both, we can't divide it. So here's our two answers for example 4. And this is why we can't just rely on graphing. I can't get these answers using my graphing calculator. So we have to still know how to solve equations by hand, specifically for when we need to do something like this. Let's continue on. And example 5 is going to be somewhat close or somewhat similar. So the future value of a simple interest investment is given by S equals P times 1 plus RT. What principal P must be invested for T equals 5 years at a simple interest rate of R equals 10% so that the future value grows to 9,000. So very complicated if we don't know how to use this formula, but formula is not that bad. Here's what everything stands for. My S is my future value. And it tells me right here, the future value grows to 9,000. So here is my S. This P stands for the principal. And it wants to know what principal P. So that means we're not going to know what P is. That's what we're going to end up solving for. R equals my interest rate. And interest rate, when we put it into this formula here, always needs to be in decimal form. So if my R is 10%, that means the decimal is back here. We're going to move that 1 2 times over. So my R equals 0.1. And then T is time. And they tell me exactly what T equals. T is 5. So let's substitute everything in. We have S which is 9,000, equals my P, we don't know P, that's what we're solving for. 1 plus my R is 0.1 times my T, which is 5. So I'm gonna put everything in parentheses in my calculator. Since that's all numbers in there, we can just get a one number answer here. So 1 plus 0.1 times 5 gives me 1.5 in parentheses. And so now how do we solve for P? Well, this is just P times 1.5. So let's divide that over. And we get that P equals 6,000. And we're talking about money, what principal money? So we could put out $6,000 for my answer here. So if we invest $6,000 at a rate of 10% in 5 years, we'll be at 90,000. Or, ooh, that would be nice. We'll be at 9,000.